Hello, my name is J. Allen Jackson. I'm a professor at the Rochester Institute of Technology. I have a joint appointment in the School of Interactive Games and Media and the School of Mathematical Sciences. My presentation today is called The Caribbean Trapezoid. It's a sci-fi mixed reality platform for teaching computational thinking. So to start off with just an overview, I'll be giving a background and motivation for the project, and then we'll get into a little bit of the story and take a look at some of the resources that have been developed here in order to use this as part of a course, an introductory course in computational thinking. So the background here actually goes back a couple of years ago when I first learned about the possibility of Unity Link coming out, and I got very excited about it because of this fact that I'm in the School of Interactive Games and Media and the School of Mathematical Sciences. I thought it would be great to use Mathematica and the Wolfram language in some of the math courses that I'm teaching, and then have something like Unity Game Engine to be able to let students see how the mathematical concepts that they're learning about vectors and transformations, how those could actually be used in some fun ways and some interesting ways, but also simulating sort of the real world. So I've been working on some combinations of exercise games and music games, and I had something that I developed called the syncopated surfing ring. You can sort of still see a little bit of that here with those are surfboards around the peripheral here. Then as it turned out, I had been collecting K-cups, these non-recyclable capsules that, and I started to think about what use I could put those to, and I had been putting together a large string of them to use to demonstrate the idea of Bezier curves. And then as it turned out, I kept collecting more and more and more, and I've got way too many of them. So then I had to think of something else to use it for. So this idea of creating a little model of a sailboat, which I called Riff Raft, came to me. And then this whole idea of the Unity Link, I thought, well, I could make something like a surfing, or rather sailing simulation. And actually, I see Todd Gailey's here. So a year ago, he gave a talk where he showed how he had equipped his own sailboat with all kinds of sensing gear and being able to capture that data and optimize sail settings and headings and so forth. So I got very interested in the use of this same kind of technology here. So my original plan was just to try to use something like this to demonstrate, of course, the ideas of vectors and forces. So that's sort of where things started. But then I had the opportunity to create a course for freshmen in science majors, and I thought, what better way to start them off in programming but to use Wolfram language. And so then I started to think, how could I take this whole far-fetched scheme involving riffraff and so forth and incorporate that into all these other kind of desired types of considerations that I wanted to take into account in this course. So let me just try to read a few of these to you. I see that the font is maybe a little bit too small, so maybe it'll help if I read these. So I wanted to have some innovative alternative to the AP Computer Science Principles type course. And so one of the things I wanted to do, of course, was use Wolfram language here. But also I wanted it to be, one of the advantages of Wolfram language, as everyone here presumably knows, but it's deep enough to provide a really strong basis upon which then they can later build extensively on their own. So these are non-computer science majors taking lots of other courses, so they don't have a lot of time to take other programming courses necessarily, but yet as they can start taking advantage immediately of what they've learned with the Wolfram language, and there's plenty of resources out there for them to learn more independently and as the need arises while they're taking courses in their second, third, and fourth year. I also thought I wanted to be able to have something that allowed them to immediately start taking advantage of what they've learned, and in their subsequent college courses. Of course, math courses and physics courses are obvious examples, but also biology, chemistry, what have you. I wanted to prepare students to pursue numerous diverse and newly emerging career options. As if you've read Stephen Wolfram's blog, you probably recognize this quote where he says about computational thinking, pick any field X, there is either now or soon will be a computational X. And so I think very strongly that we need to be preparing our students for the types of careers that we can't even imagine right now exist. I know when I was studying mathematics and computing early on, I hadn't imagined that I would ultimately end up in a game design and development degree program teaching that. So, of course, motivation is important in engaging science students by letting them perform computational experiments and making interactive simulations and visualizations. I think that's a real strength of the Wolfram language. And then when we combine that with using Unity Link to have the Unity game engine, that gets even more, offers even more possibilities. I think it's really important. We in the game design and development school, we have many group projects that our students work on, and I see the benefit of them being able to start working in teams and taking advantage of all their different strengths from various backgrounds. So developing group problem-solving skills was another important consideration, and then letting them be creative, building original works that they can share with others, both to teach and to just be excited about, let's say, giving performances, live coding exhibitions, even things like esports. To incorporate all these different elements of exercise, entertainment, enlightenment, pretty much anything that starts with an E, I suppose, combining that with educational opportunities, providing experiences that are analogous to what they get by being, let's say, members in music ensembles, sports teams, math, computer programming, science clubs, theatrical and dance troupes. I guess I didn't include here like a debate team, but I'll figure out some way to incorporate that as well. Then lastly, I think providing experience with being in the field of science, you don't just read things off a thermometer anymore. You've got digital devices, and the connected devices capability of Wolfram language is extremely important here. They can capture and process sensory data from cameras, microphones, accelerometers, and then also I think being able to use machine learning. That's an exciting prospect that in most introductory programming classes you'd never be able to get quite that far, that you're actually incorporating state-of-the-art machine learning in that. And then lastly, again, in reference to Stephen Wolfram, I really liked the idea of computational essay as something that students can be involved in writing themselves and so forth. So I wanted to further stretch that notion to include what I considered like a computational sci-fi tale, where they're doing some creative science fiction writing, but it's not so far from the truth or reality that it's useless. And the idea then that you could have a Unity game engine be like these pop-up books, right? Where something suddenly comes to life and they can create a simulation of a situation. Those are all the, like I said, the considerations that went into this. So the actual story here is that there's lots of acronyms here, but a group of scientists, this is what the students will be playing the role, that they're a group of scientists from this Cetacean Intelligence and Communication Investigation Lab, and they're undergoing training for an upcoming voyage of discovery to a peculiar and desolate area known as the Caribbean Trapezoid. As far as I know, there's no way to, in the Wolfram language right now, there's no fundamental thing that will draw a Caribbean trapezoid, but we'll be extending that. Now, a robotic sea turtle named AIMPS, Artificially Intelligent Multisensory Signal and Pattern Perceiver, will accompany the ship Riff Raft on the exploratory mission. I had originally thought about this idea of if they were on board this ship, they would have like a ship computer to help them with navigation, figuring out which way is the wind blowing and the current going and where should we head and read the bottom and all that. And then I started to realize how much more interesting it would be to have AIMPS be embodied as a sea turtle. Now, I had to, coming from the Caribbean here, AIMPS not used to the colder climate, so I had to warm them up a little bit. But so this is the idea of our robotic sea turtle, and you can see we've been working on a 3D design for AIMPS that ultimately part of what the researchers will have to learn how to do is control AIMPS so that it can go out and move around, execute roll, pitch, and yaws. But much more than that, AIMPS is, because it's robotic, will have the capability of making sounds and having lights. The very distinctive pattern on the back of the sea turtle here, as it turns out, if you just divide here and here, then you end up with 12 hexagonal or polygonal regions around here, and of course 3 hexagons right in the middle. So you'll see how we were able to start making use of that for AIMPS to have a lot more capability here. Let me see if I can scroll down a little bit. Yeah, so that's yet another picture of Riff Raft here. You'll notice that there's some other things. This is set up actually right outside my office. I waited until the weekend and then flooded the hallway here so I could do some real sea trials. But again, there's the K-cups being used out there. I've got a boom that's functioning as it's actually a boom stand functioning as a mast and boom. And there's all kinds of repeated patterns in here, not only the piano keyboard pattern, but then the coloring, going from red to yellow to green to cyan to blue to magenta. So these themes are all repeated. You might not be able to detect this. This is actually a drum hoop, and with lacing, again, with the same coloring, using parachute cord. So let's see, I'll go ahead and get along here. So So here's the addition to the story that the researchers from CISL become aware that there's a troop of wild yet playful dolphins known as Apod and they've taken refuge in the Caribbean trapezoid. But despite an intense curiosity that strongly attracts them towards harmonious syncopated tunes, rhythmic movement, and colorful geometric patterns, they cautiously remain distant and avoid direct engagement with humans, contrary to typical tropical cetaceans. So consequently, AIMS will be sent as a harbinger to convey universally meaningful and friendly intentions, and undergoing instruction on how to exhibit expressive body language by the crew of Riff Raft, be able to then generate enthralling sounds from the squad at CISL and hopefully attract and engage with the dolphins here. So this is where AIMPS came up with the idea that could conduct clever and catchy interactive song and dance routines composed from myriad mixes of music, motion, math, and media, and draw a pod calypso to observe and eventually perform in synchrony, thereby producing close encounters of the nth kind. It's awfully quiet out there. You guys are just disbelieving? Okay. You weren't prepared for this, I suppose. I thought the title was giving enough of a hint that this was not going to be completely as realistic as some of the other talks perhaps you've been to. Now, I think an important part of students' education, as I said, all those E's, exercise, entertainment, and so forth, but enlightenment, I think, is a very important part that's often overlooked in education. And that first quote from Albert Einstein is something that I think is really important, has affected me. AIMPS came up with his own, well, we're not really sure, I guess we should just call it. But again, this idea that knowledge without kindness, I think, is really quite flat and dimensionless. I think we need to incorporate that more and more. Kurt Vonnegut is one of my favorite science fiction writers, if he's not always considered science fiction writer, but I probably don't share too many things with him other than the fact that when I do write, I do feel like an armless and legless man with a crayon in his mouth. So this is where I've penned kind of my own little bit of story that my students in a class that I'm teaching this semester haven't quite seen this story yet. I've been hinting to them that now that we've passed midterm, things are going to get a little bit crazier, but more creative. I'm expecting that many of these students are going to be wanting to write their own version of a story, and I think that's a great part of this idea of computational essay, that they can mix writing, creativity. We're going to see like music making, dancing, and movement, sports, all these elements they can bring in and kind of come up with something that they can make their own. You got to be careful. Yeah, make their own. So I'm not going to, in fact, read all of this part here to you, but this will be posted. You can download it and read it yourself. And I think it sort of lends itself to further extension and maybe even making something that's possibly more believable. But actually, if you've read anything at all about dolphins and what they do in dolphin research, dolphin communication and intelligence research, some of these things are not that far-fetched, actually. A lot of researchers, you can go look at some TED Talks. There's a researcher who's been working with someone from Georgia Tech to design interfaces that would allow divers to be able to communicate with dolphins, get them to play games, get them to understand certain types of not only gestures and symbols, but dolphins themselves. It's well known that even though there's much that's not known about communications, dolphins have their own signature whistles. Every dolphin has a unique type of pattern that it develops, that it has, and humans have been able to get dolphins using synthesized signature whistles. They've been able to get dolphins to sort of adapt their convention, like this signature whistle means a ball, or this one means a piece of rope, and when the dolphin wants a toy like that, they can quickly pick up on, if they make the right signature whistle sound, imitating a real signature whistle of some sort, then they'll be able to get it. So a lot of these ideas we're incorporating into our experience here. As I said, the course that I'm teaching this semester, the students have been working on going through we went through the first 16 chapters of Stephen Wolfram's Elementary Introduction to the Wolfram Language book, and then they're now, while I'm away this week, they're working on their own through the graphs and networks, along with the machine learning. But the next thing, after they took the midterm, which was pretty much just a recognition of basic Wolfram language, the next thing that I had them do, and this is what they're working on while I'm gone, is various types of pattern recognition exercises, being able to take some Wolfram language code, understand what it does, and then extend it to do something more. For example, here's something that we've been doing a lot of, just discussion of binary patterns and so forth. And so here's some code that generates this, and then I'd give them something like this and say, okay, now you figure out how to extend it like that. And I think this works very well to start to get them away from the fairly elementary but useful exercises that they go through in the beginning, and then get them into the starting to be creative and invent their own things. So I know I don't have time to go through all of these examples here, so I hope those of you that are interested will take time to do it. Like here's another example where they've given something that already does something. sorry, give them something that already does some kind of a function here, and then give them something else and to ask them to combine that with the previous code up here and then be able to produce something that would do something like this. Yeah, and then lastly, of course, I'm told that I'm not able to play any audio for you all to hear it, so that's unfortunate. But again, if you go to if you download the notebook here, you'll be able to do a little bit of these exercises yourself if you want. Eventually, wanted them to be able to develop the code that would generate a pattern like this, and you can see now what the actual potential is for AIMPS to have the colors and so forth on here. So when AIMPS is out interacting with a pod Calypso, there'll be a song playing and there'll be lights going on. Now what I imagine is I'm not going to probably get real dolphins, so I'll probably have what I call dolphin impersonifiers, impersonificationists, what am I calling it? Impersonators. These will be kids, let's say, that have these dolphin puppets with the accelerometers in them, and they'll be able to learn how to follow AIMPS and dance along with it. And so I think there's a lot of potential here for developing this further. The following talk now coming right up is, again, Ashwin, who's going to show some demos and talk about all the work that he did to develop it. So anybody have any questions?